Ah bah,
Hello.
salut Semaine. J'étais en train de chercher où est-ce que je faisais le claim host.
Ah, c'est.
Je trouve
On va
ça.
accélérer, c'est bon?
Non, non, toujours pas, mais je.
Ah, il y a une personne qui est arrivée en avance. Désolé, on va devoir te mettre en liste d'attente. En fait, ça arrive vite.
Ouais, tu m'étonnes.
Alors. Alors, comment on fait déjà? Pourquoi c'est en recording alors qu'on n'a pas demandé à record? Ça, je ne sais pas. Alors, je le fais ou je le fais? Je le fais.
Vas-y.
Je le
Parce que moi,
fais, je te mets en coparticipant.
j'ai toujours pas compris où est-ce qu'on claim host.
Hi, Matt.
Hi, folks.
Hello, Matt. How are you doing?
Lancer.
We are just polishing a couple of things.
Yes.
No worries.
So we have to make the participant in the waiting room. I'm sorry, but we have to move the ones we joined in the waiting room. Okay. And I'll put you as the co-hosts, you both. Make co-host. Yes.
Yes, I received additional powers.
Cool. So we're gonna wait a few moments until the start of the beginning of the event. While we are waiting, maybe you can check how you will share your screen if everything works good. Matt?
Yeah, well, we can do that. Wait 1 second.
Nice to meet you, by the way. I'm sorry. We were,
Nice to meet you too, finally. We've spoken a lot on email over the last couple of years.
Yes.
Where am I? Hang on a sec. I'm going to share this one. Let's just put that over here. Let's do that. Can you see that?
Yes, it's working perfectly.
Good.
Perfect. So I don't know why, but the recording has started automatically. Maybe you can pause it while we are waiting for the other attendees.
Yes.
Yep. Get this.
And I'm starting the registration.
Yes, I forgot.
The capture for the recording. Thank you. I was looking for the word in English. So it's up to you. You can share your screen.
Something I forgot to mention. Don't hesitate to ask your questions all along the talks. We will do a few pauses, maybe every 10 minutes to answer the questions. So don't hesitate and don't wait until the end of the presentations. Thank you.
Okay. Okay. Great. Welcome. Thank you, folks, for having me. I'm Matt Jarvis. I'm a senior developer advocate at a company called Sneak. Sneak build cloud-native security applications with a developer-first mindset, and that's kind of what we'll be talking about in this talk today. My background is I've been around both product development and operations of distributed systems for a pretty long time. I've worked for a whole variety of companies in the cloud native space. I was previously at D2IQ, Mesosphere. I've been at Canonical at IBM. So yeah, I've been around this space for quite a long time. So the story of the last decade or more in software development has really seen the boundaries of what is an application what is operations and what constitutes infrastructure become increasingly blurred. And the old view of the world that we can see here was that the application was the only piece under the responsibility of the development team, and all the other elements of that stack sat under IT operations, with security usually being a step right at the end of the deployment process. But the world we live in today is one where our infrastructure and our workloads are almost completely tied together. Everything's declared as code, everything's a software development practice, and there's really no difference between our workload and the computing infrastructure that goes along with it. And by infrastructure, we don't just mean the underlying compute technology, but also the configuration and the operational policies that control those capabilities. And as a community of practitioners in this space, we've discussed in lots of detail this blurring and eventual consuming of the boundary between development and operations, which gets us to DevOps. But in lots of cases, we really haven't considered how that impacts on how we model and practice security. In a lot of organizations, security is still considered to be an external practice. It somehow exists only once our applications are deployed and operational. But this is really unworkable in the era of continuous integration and delivery. As we've seen, developer-driven teams now have responsibilities for most of our deployment stack. And so this gives those teams a much greater responsibility for ensuring that those things are secure. So by the time our code and our infrastructure is deployed to production, it's really far too late to deal with the implications of security issues. And we can't slow down that velocity to introduce security gates in the way that things used to work, because velocity and the time it takes us to get to market is clearly the differentiator for businesses to succeed in the cloud era. And that presents us with a set of unique challenges around security. How do I make sure my applications and infrastructure are secure when our working practices are evolving into these super fast delivery pipelines? Security still matters. And as we've seen repeatedly over the last few years, security breaches can have a really big impact on businesses, both from a financial perspective in terms of bottom line and potential fines, but also on how trusted our customers see us as. And trust is really one of the key metrics for successful businesses in the internet era. So first, let's take a look at the different classes of things we probably need to be looking at to ensure that we have security considered in our workflows. So firstly, the applications that we're creating, our workloads. Modern applications are usually composed of a relatively small core of homegrown code, along with a huge amount of third-party code, which is usually open source modules. And this is great news for application development, since the availability of modules means we get to develop applications faster. We need to write less code. We don't need to reinvent the wheel all the time by solving the same problems over and over again. And anyone who develops in Java, in Python, in Node, in Go is going to recognize this pattern. And in all of these ecosystems, the number of vulnerabilities is growing. Now, this isn't necessarily because code is getting more insecure. It can be just there are more modules being written, there's more code out there, and that we're getting better at working out what a vulnerability is. But in the end, this all means more opportunities for these vulnerabilities to be exploited. And each of these, the modules that we include can have a large dependency tree, both in terms of direct dependencies, so things that this package depends on, but also indirect dependencies, things which those dependencies depend on. And that can potentially bring in a lot of other modules which we might not even be aware of. And typically around 70 to 80% of all security vulnerabilities are found in indirect dependencies. So those ones we weren't really even aware of that got brought in by something else. So as an example of that, let's take a look at this. This is an exploit from the Node community that was introduced into NPM in around 2018. And this get cookies package is supposedly a library to parse HTTP headers, but it's actually a remote execution exploit. And it's about 40 lines of code, and it'll process remote JavaScript code and then execute it on the server via the use of specially crafted commands in the HTTP request. And it was hidden behind a tree of other dependencies. And then the direct dependency eventually ended up being used in this mail parser package, which has a huge amount of downloads every month. So it's pretty easy to see how in big developer communities, these kinds of indirect dependencies can be used to hide exploitable code. So vulnerabilities in third-party dependencies is super important because they make up such a large part of our code bases these days. But as we said earlier, the line between our application and the container it runs in is becoming increasingly blurred. The container is the delivery mechanism for the application, typically developed at the same time, maybe even by the same team. So for all intents and purposes, we can consider them the same thing. They're part of the same deployable workload. And like the availability of library code in our programming languages, the huge growth in container registries has been great for the ability to run pre-packaged software super easily and for us to consume that in our own infrastructure. But they're also a source of vulnerabilities. And when we look at the container landscape, although best practices are emerging around things like building your own containers using minimal base images like distroless or Scratch, there is still a huge amount of people using containers directly from these upstream repositories. And many of them can have very significant amounts of vulnerabilities in them. And so we're presented here with lots of possibilities for attack vectors, and because that responsibility for security has been pushed to our developers who are developing these things, it's the developers who really need to understand this. And there's also a long tail taking the path of least resistance by giving applications containers based on a full operating system. And when we look at operating systems in general, the amount of vulnerabilities in base operating systems is really massively growing, partly because operating systems by design ship with a lot of software in them. And in some ways, the idea about using operating system-based containers to deploy workloads in containers, it sort of breaks the paradigm of what we want to do in a container, i.e. just ship our application and nothing else. But there are still a lot of people using these kinds of images for container deployments. And this slide is also always interesting for me. We can also see that a lot of people don't think about emerging vulnerabilities once their workloads are in production. So an image that you use when you deploy that workload may now have vulnerabilities in it, which hadn't been discovered when that image was built. So if you're not looking at containers you already have in production, then you're never going to find out that they are now vulnerable. And fixing these things usually isn't very hard. Over 40% of Docker image vulnerabilities usually be fixed by upgrading the base image. And around 20% can be fixed just by rebuilding them, since a lot of containers will run upgrades during that build process as part of the Docker file. And as we've moved wholesale into cloud and now into things like Kubernetes, configuration is almost entirely in code. And it's part of our development workflow again. So we're developing Kubernetes YAML when we develop our application. And by configuration, we can include all of that YAML. We can include Helm charts, any automation we might be running, Ansible, things like that, Terraform. and all of the policies and things that go alongside that. And this is a really massively growing field, as we can see from the amounts of this kind of code that's in GitHub now. And we really are only just starting to view that as something that we need to consider from a security perspective. Kubernetes is increasingly complex. And as we've moved the responsibility for developing this kind of code into our development teams, there's clearly a lot of space for misunderstandings about how things work. You know, I mean, I certainly speak for myself that there are a lot of things in Kubernetes that I don't understand fully. And as we compound that with things like service meshes, we increase that complexity even further. And with this much code out there in GitHub, we can sort of see the potential risks of taking that path of least resistance. I'm just going to take this from GitHub, use it as a template, and perhaps I don't fully understand how these things work. And so we can see the possibility for risk there. And this is all really important in the security of our environments. This quote from the Open Web Application Security Project is a little old now, but still proves the point that a huge amount of security breaches are coming from misconfigurations in infrastructure. And as I'm sure most people are aware, if any of you are running these kind of things in production, I've certainly had real world examples of this, things like leaking cloud credentials or clusters becoming infested with crypto miners. And this is all coming from misconfiguration. And when we look at this space in terms of Kubernetes specifically, it's important to note that Kubernetes doesn't have any guardrails for you. You know, if you're using the upstream version of Kubernetes, it's insecure by default. You know, that's by design, because Kubernetes wants you to make those decisions for yourself. So we can look at some of the implications of some of these things. So by default, there are no resource limits set, which means that a pod can consume as much resources as the kubelet will allow it to. This has the potential for denial of service attacks. And those denial of service attacks can affect a much bigger scope than just a single application. We could potentially take a node offline. We can potentially cause more problems when workloads move around in the cluster. And we also have, we can allow containers to run as root by default. And this becomes a big problem when you look at the amount of containers in things like Docker Hub, which are configured to run as root. You know, this opens up major security applications. A compromised pod running as root has the potential to escape the container. And so we really need to be limiting the potential for these kinds of attacks. There are very few applications which need root access to run. And writable file systems inside containers are also a real risk point. And this again is by default. We have rewrite file systems, and that allows, if my container is compromised, it allows an attacker to download software, allows them to change configuration, and potentially increase the blast radius of that compromised container quite substantially. So having our containers read-only sort of starts to prevent an attacker from being able to increase the scope of a compromised container. And the same applies to capabilities. You know, the classic one here is people running containers in privilege mode, and privilege will basically give you all of the capabilities that you get as root on the host node. In almost every case that I've seen, unless you need to manipulate the network subsystem or you know, access dedicated hardware, you really don't need significant capabilities to run most applications. So the idea of least privilege is really the one that we want to be following here. You know, find out exactly what your container needs and only give it that. So where do we start in terms of thinking about solving some of these problems in terms of modern Git-driven workflows? And you know, the answer to that really is that we need to shift our security practices right to the left of our pipeline. So we embed security all the way through our development workflow. And we share that burden of security responsibilities across our development and engineering teams. And this is really this idea of DevSecOps, that we start to integrate security directly into our DevOps workflows in exactly the same way that we merged development and operations over the last few years. And the most obvious place that we start is right at our application developers. We need developers to have insights immediately into potential security issues, but we need that to be tightly integrated into their workflow. And so that means tooling that's available from your local command line. It means integrations into things like IDEs. And this is all aimed at reducing the overhead for application developers to use these tools right at the point they're working, before code even gets into our repositories. And the tooling that we use has to provide developers with the right information to be able to make security decisions. Not just lists of CVEs, which is not really very useful to anybody, but tools that give us insights into how severe vulnerabilities are, how exploitable they are, and that also give us remediation advice. So how do I go about fixing this? You know, do I just upgrade a package? You know, do I need to apply a patch? And as we saw earlier, we want to be looking at those third-party dependencies, what's going on in our container images, and in all of our infrastructure code. And you can do all this with Snyk for free, but there are, you know, plenty of other security tools available in this space. So our second touch point is clearly our source code management. In almost every case these days, this is Git. Our Git repository is now the single source of truth for everything. It's for our application code, for our infrastructure code. So that has to be secure. Git itself has been pretty secure over the years. And in most cases, folks are using hosted Git services like GitHub, like GitLab, which have been pretty good at security. But there are definitely process-related things to consider here. By its nature, Git can open you up to certain things, and our users need to be aware of what those things are. So we want to be enforcing two-factor authentication and making sure that our users have strong key security practices and that they're keeping Git up to date locally. Exposing private data is always a risk, particularly in commit histories. This is the piece about where we can get cloud credential leakage. You know, the most common thing for this is that at some point in a repository's history, a key has been used and it's then been removed from the repository, but people haven't realized that all of that information is still contained in your Git history. Configuration data should never be in Git unencrypted, even in local repositories, for exactly that reason. So we want to educate users to use things like Git ignore files to not include any kind of secrets data in repositories. It goes without saying that we need strong review processes, and this is really about the human aspect of this and making sure that our processes are correct and are being followed. And where we can, we want to be enforcing things with automation, things like pre-commit hooks, so that we don't have manual process around this stuff. It all just happens as part of our development flow. So once we're confident that Git is secure, we can start to leverage automation. And what we want to be doing here is that on every pull request, we want to be looking for the same issues that we were catching at the local development stage. But this time, these are going to be automated. So scanning our container images, scanning our container, our Docker files, our third-party dependencies, our infrastructure code, every time something changes in this repository. And the key difference here is that because these checks are automated, we're also monitoring for things that might have changed upstream since a particular piece of code was committed, even if our code hasn't necessarily changed. New vulnerabilities are discovered all the time, and code that didn't show vulnerabilities when it was first committed might now be vulnerable. So these kinds of monitoring scans over time will allow us to pick things up right in the code repository where it's relatively easy to fix. And our container registries also fall into this category. And nothing's fixed in stone, so an image that looked fine when it was built might now be vulnerable. Excuse me. So if your registry has built-in scanning, which many do, take advantage of that, or use tools that will integrate into your registry. And most automation around container registries will be doing scans on rebuild. And we also want to be looking at scanning on a regular basis, even if we haven't changed our images. That base image that we used might have new vulnerabilities. And a lot of people don't rebuild their images unless they actually get changed. Another key integration point is our CI/CD system. And again, here, we want to be scanning for exactly the same things. We can scan our images here, we can scan our code. And because we're rebuilding everything at this stage, we're going to catch things that might have changed since things entered the source code repository. And we want to be looking for tools that we can integrate really easily with a whole range of different continuous integration, continuous deployment tools. And then the final place that we want to be looking is our production environments. Containers in production, particularly if they don't change very often, can end up with vulnerable images. So we need to look both at containers that are being spawned and containers that are already running. And in this space, we can also take advantage of admission controllers, things like pod security policies or open policy agent, so that we can actually gate things based on security policies that don't comply with what we're looking for in our cluster. And that we can potentially gate on whether our images have been scanned in our registries to try and stop things that are hitting production if they don't comply with our security policies. And we can also look in runtime for other things around runtime behavior. And this is a kind of emerging space. We can look at tools like Falco or other things in the runtime space, which are looking for erroneous activity during runtime. And I think over the next couple of years, we're going to see many, many more tools in this space, where we'll be able to look at, have things changed in a particular image? Has a binary been changed? Is a behavior happening in a different way than what we expect of that particular application? And in production, we also want to be looking at controlling our network policies, making sure that containers can only communicate with other containers that they need to communicate with. And so we kind of, if we do ever have a compromised container, we've got control over what the blast radius of that particular compromise might be. So the takeaways from all of this is that we need to shift our security left along that pipeline, and we need to empower our developers to make decisions on security based on giving people access to modern tooling and process. In this new world, security teams can't be gatekeepers anymore with control over deployment. We need to consider the role of security professionals to be advisors and toolsmiths as opposed to gatekeepers, which will allow our development teams to continue to deliver applications, new features, new applications as quickly as possible. And we need to build in visibility and remediation of security issues all the way through our development pipeline. So leveraging automation to scan our third-party code, our container images, our infrastructure code, and what's happening in runtime. So that's all I have. Thank you for listening. As I said, you can try this kind of stuff out with Snyk, although other security tools are available. and I'm happy to take any questions.
Well, I may have one question because I actually don't know SNCC, but I worked on the evaluation of other container security platforms, such as Equa or Twistnik, Prisma Cloud, sorry. So what is the main differences of SNCC?
So SNCC's really focused on that, on surfacing this stuff to developers. So not just about saying this is potentially happening, but on providing remediation. So in a lot of cases, automated stuff. So, you know, for example, around the third-party open source libraries, you know, SNCC can actually suggest which package version you need to upgrade to and create a fix PR automatically. So that's the kind of direction that we're going in, is to really focus on the developer, because, you know, the responsibility for this stuff is becoming more and more about developers, and, you know, providing developers with long lists of CVEs just isn't helpful. I mean, you know, if you look at, you know, we used that node example earlier, you know, if you look at some of the node-based images and you scan them from any container image scanner, you're going to come up with like, you know, 300-400 vulnerabilities. Well, I'm a developer sitting there looking at that going, well, now what do I do? Okay. You know, so it's really about trying to introduce ways of automatically fixing that stuff, and to present the information in a way that's useful to developers at the places where they work, rather than now you have to go over here to this security system and check this. You know, it's about integrating into that developer flow.
Cool. That's clear. Thank you. Any other question?
You can send it
talk
in the
French
chat
if you want. Sorry? What?
No, I just want to say you can send it in the chat.
Yeah, you don't need to unmute. Put it in French, and I'm sure these folks will translate for me.
No question. No question.
Pod security policy versus open policy agent. Well, that's a very good question. So pod security policies are actually in line for being deprecated. So I suspect that the best option, if you are looking at implementing admission controllers around security in your clusters these days, you are better looking at open policy agent. There are a lot of complexities with pod security policy, which can cause people big problems in operations, which I think was one of the kind of the motivations for deprecating it in core Kubernetes, was that it was very difficult to produce something that was generalized enough to work across the board. I've certainly struggled with setting pod security policies up quite a lot. So I think the general movement is towards external solutions like OPA, but I think OPA is absolutely fantastic tool set for doing this. We actually use Rego in our configuration management scanning. And so I think we're going to see a lot more development in that area. So I would highly recommend looking at OPA.
Thank you. Any other question? And if there is no other question, I think we can move to.
Thank you, folks.
Thank you, Matt.
Thank you, Matt. Thank you a lot.
Thank you, Matt.
Our next speaker is Romaric Philogène. Did I say it correctly?
It sounds like it. Yeah, very, very French. and you can hear. Okay, thanks for having me. It's very pleasant to be here. So what I'm going to talk to you is about NATs. It's very quick feedback of using NATs at Covery, because I know by discussing with the teams behind the project, which is a CNCF project incubated one, it's not a very well-known product, but you can be sure that it's something to consider when you are starting startup like we are doing. So just, So first of all, just a quick word about me. So I'm Romaric. I'm the CEO and co-founder of Covery. I used to be, but I'm still, because I'm very passionate about what I'm doing, developers. I've worked on infrastructure, mostly in the financial industry, where I met my co-founder. And I decided just to launch Covery to help all my peers, all those companies that try to build some product and focus on their business instead of the infrastructure. Just a quick word about Covery before getting into NATs, because it's very important to understand the context. We are a cloud native platform. So what we do basically is that we have developers to deploy their application in the cloud on any cloud provider without having to manage the underlying infrastructure. So the only things that you need to do as developer is to get into the web console that we have. Then you can select the project that you want to deploy on GitHub, GitLab, Bitbucket, and that's it. You just have to click, and Covery takes care of the provisioning of the infrastructure on the cloud provider of your choice and the deployment of our application. So that's very important, because at the end, what we are doing is that we have created this control panel, this application, this platform that makes you able to just get into the control of your cloud provider. So when we are talking about the different PCs that are installed on the different cloud accounts, we need to make our applications communicating all together. And to do that, we're using, obviously, NATs. So as I told you, NATs is a cloud native messaging system. It's quite interesting to just compare very quickly to the well-known one like RabbitMQ and Kafka, because the concept of NATs is not something new, but it's the combination of both that is quite interesting. So we are going to dig into those features, and by our experience with Pierre, my co-founder, we just decided to get into something much more simpler than what you can get with RabbitMQ or Kafka at a large scale. So NATs is a very good candidate. So just to show you how easy it is to get started into NATs, they provide everything that you need if you want to start to use the product. So by providing templates for Kubernetes or even for NATs, so you have an image, you don't need to do anything special. The only things that you need to do is to run Docker if you want to get started to develop locally. So you can see in just a few milliseconds, the application is starting. So that's pretty great. It's not important to talk about that. It's just a low memory consumption that you already know. So in terms of usage, what you can see is that you have two modes in NATs. You have the synchronous mode and the asynchronous mode. What's good is that they provide multiple drivers. So for all the most popular languages, at Covery, we are using Go, we are using Rust for many reasons, Java, and sometimes we are also using Python. For all those languages, you have the drivers that you need. And even if you don't have one, you can get or grab one from the community. There is a very good active community. So just to show how we are using NATs at Covery. So we have this concept of a multi-cloud provider and multi-region. So for each customer that we have on our platform, we need to install Covery on their side. We are not a hosting platform. We deploy the application on their cloud account. We simplify the way that they get access to their cloud account. Matt has just told you that he doesn't know how Kubernetes is working in the specific details. most of the developers and even people that are working on Kubernetes don't know. That's why we have created Covery. And to send those messages, so we are using NATs. And what's important is that we have this ability with NATs to connect. So once we have deployed the engine, the different engines, what we call the engine, that's the part that is in charge of the deployment. When we have deployed those engines, they are able to connect through NATs, and then our control plane can send all those requests to those engines. So that's very basic concept of messaging system. But what's interesting is that we really need to have a kind of dynamic systems. We need to plug as many engines as customers as we have. So we really need to have the declaration of those, what we call subject dynamic. What does that mean? It means that when we have a customer that is starting to use a Covery for the first time, so he provides all his different APIs keys, then when Covery has all those keys, then he can start to install Covery on their cloud account. And to start to send message, then we are using kind of address, so which is starting by engine.something. So it's a very simple one that we provide here. But the idea is that you can start to partition the way that you are going to send message, like an address. So if you want to target by sending a message to all the engines that are from customer one, you just need to use engine.cust1.star. So you have kind of a wildcard that you can use, and then you can start to target all the engines that are used by one customer. This is very convenient, and this is the way that we start to manage at scale multiple customers. So NATS is very cool for that. We have the concept, so built inside NATS, you have the concept of a queue group. So for each queue for each subject that you create, you have the ability to dynamically allocate what they call a queue group. So let's imagine that you have, for instance, 100 requests that are coming inside your topic, your subject, and then you don't have the ability to consume as fast as you get those requests, then you can put a queue. This is convenient because, and at the same time, what we are doing at Covery is that when we see that an engine is really used by a customer, for instance, if he starts to launch multiple jobs, then we can upscale the number of engines. Then all those engines are connected through the same queue and subject. Then they can consume and consume and consume. And when it's done, then they start to live. What happens if you lose then the queue system? The engines, if you lose the connections or anything, then you keep the message because you are using a queue. If it's not the case, then NATS can't keep the message and you are in the mess. So that's why you have to, if you are using the system intensively, you're better to consider to use a queue group. But there is something to consider with NATS. If you have a slow consumers, you have low performance. What does that mean? It means that it's based on the same principle of event loop. When you are starting to send a message, you better just to fire and forget the message. If you start to wait for a request, because you can wait for a request, and then if it takes too many times, then you block all the receiver, all the producer, and you have low performance. That's not good. So if you are using intensively like we are doing NATS, you're better to use what they call the publish method, so fire and forget one. So I told you that NATS is the combination of RabbitMQ and Kafka. Kafka and RabbitMQ are not the same at all solutions. They are responding to different needs. So RabbitMQ is much more AMQP, it's a queuing system. Kafka is mostly like almost a database. But what's interesting is that with the NATS solution, it's much more like a RabbitMQ. You don't have the persistence, okay? With Stan, then you get the persistent, the ability to just replay all the things in the way that they come. It's like very similar. It's the same concept as what you get with Kafka. The problem today is that Stan, so it's the project that is giving the Kafka features, is not as mature as Kafka. So if you plan to use Stan as Kafka, maybe it's not gonna be the same. So just to be careful about that. I know that the team is working on a new version of this. We decided just to remove it from our style because we want to keep it as simple as possible, but we really consider to use it. So we are waiting for this improvement. There's one little problem that we didn't find in the documentation, is that the queue group, when you start to put a queue on your subject, all those messages are random, are load balanced randomly. This is not good. It's good when you have tons of subscribers, so you can balance the workload. But when you want to fairly balance the workload, then it's not good. For instance, we have customers that have just like 2, 3, 4 worker subscribers, and then you get like 2 tasks on one subscriber and 0 on the other one. This is not good. That's not the way that it's working. So to remediate that, we have started to work on some algorithm by using NATs at the same time to balance the workload correctly. So it's I hope that it's going to be improved in the future, and I'm pretty sure it's going to be the case. One other little things that you have to consider is that there is no what we call letterbox. So if you are familiar with RabbitMQ, then you know what's a letterbox. But the idea is that for NATs, if you start to lose the connection, then you have a subscribe to, for instance, subject, and then you lose the connection, then all the pending messages that were assigned to you are just lost. And not good. It's not what you expect from a messaging system like NATs, but I think it's maybe a design choice. I don't really know. So I hope it's going to be fixed in the future, but to remediate that, then we have create a ping system, and we know exactly when a worker is just dropping the connection, then we resend back the information. So maybe that's the goal in the cloud native system to work. So yeah, this is very a quick overview of NATs. So just the conclusion is that so I've separated both. On the upside, then it's really easy to install. NATs is just in a few seconds. We decided at Corey to use NATs instead of all the other things because we have experience with them, and we know that it was quite painful just to maintain with a cloud native stack because we are using behind the scene on our side as well Kubernetes. So we didn't want it to manage the persistence in all those things. And when you have a solution like NATs that has been built to especially the case that we address, then it's very good, very, very good. It's easy to maintain, as I mentioned. Then you don't have, they provide everything that you need if you want to go live in production. For instance, we have all the things like operator on Kubernetes that they are provided. You have the TLS that is managed also by what they provide on that. So it's very good. It's just a one-click install and then you can go. It's lightweight. I mentioned that the footprint, you saw it when you start for the first time. NATs is just a 5 megabytes in memory. It's because it's written in Go. So very, very, very fast to be started and very low in terms of consumption. So that's pretty good. We don't have any problem with NATs actually, but we have to keep continuing to work with to exactly know how it's going to behave in the future. Scalable, you saw it. It's built to be distributed. So if you want to have multiple NATs, it's not a problem at all. It's provided, reliable, and built for the cloud, obviously. As a developer, so that's a very important part for us. we wanted to really get it started. You know, we are startups, so we don't have like infinite income. We have just made one fundraise, and we need to go very, very, very fast on the market. We want to focus just on the value that we give to our customers, and getting NATS to do what we had to do is very beneficial. In terms of experience, if you want to start to build a product and test and run all your tests, you have everything that you need, like the embedded server on Java. So if you want to run like a functional test, it's great. The API, as I shown to you, is a very easy and straightforward to use. For instance, you have one functionality that is the request reply, the multi-request, multi-reply. For instance, if you have multiple subscribers that are connected to the same subject, you can ask to all those subscribers to respond to your request, which is very, very, very powerful. That's something that you can't get from other messaging systems. And that's why it's called cloud native messaging system. So yeah, that's it, basically. It's very short and very quick feedback of NATS, but I hope to get into production for more time, because it's now for probably like 6 months that we are running with NATS in production, and then we be able to talk a bit more about some details. So thanks. Do you have any questions?
Thank you, Romaric.
Yes, I have a few ones.
Yes,
you mentioned that this streaming feature, the streaming part of NATS is not mature enough. Is that right?
Yeah, yeah.
Did you face any issue? Can you elaborate on that?
We didn't, to be honest, but we didn't want it to be exposed to any issue, to be honest. We wanted to keep it simple. And you know, when you start to add like the persistence layer, you are a bit afraid of. We wanted to wait for some more mature feedback. It's not the case, you know. Even NATS is a quite early project. It's not early one because it exists for a long time. There's people using it, but it's not very famous. So and that's, you know, the goal of this talk is to show to the community that NATS exists. And if they want to be involved to make it more mature, then it's good.
Cool. I was wondering if I understood your talk, you don't advise to switch to NATS for the moment if you're confident with Kafka. Am I right? For the same features?
Yeah, it depends on the, I guess, and you have to ask to the Synadia team, so the team behind NATS. But I would consider for sure Stan. But if your workload is like, I don't know, the critical one in terms of workload, maybe it's not a good idea. You will face to probably performance issue or things like that. But I have no experience with that. But yeah, maybe you have to. Do you have anything in mind when you are seeing that, or do you have any?
No. I was just wondering if you have a big workload, a big data set, and if it is reliable enough or performant enough to compare to Kafka. I don't know. Maybe you don't have the information.
No, I don't have the information. And to be honest, we prefer to store all those requests that are sent through NATS on our database, main database. So then we can just replay those requests if we need. But it starts to be big. Yeah.
Yes. Sorry. Given your experience on the RabbitMQ, would you advise to use definitely NATS instead of RabbitMQ for queuing?
It depends. It depends. If you need to have a reliable, very reliable systems, then maybe you're better to use RabbitMQ. The goal is not the same. It really depends, but you have to design your system depending of what you're doing. So if you want to rely a lot on RabbitMQ because on the messaging system because your system your application has been designed this way, then maybe it's. But what's important, maybe the main difference between a RabbitMQ and NAT is concerning the dynamic things, as I mentioned. You know, you saw it on NAT. You are able to plug multiple applications dynamically. Then you can remove them if you want. That's for me the main difference with a system like RabbitMQ. RabbitMQ is much more. It has been done very long time ago, but it has been done in a ecosystem that is quite static. If you need to have dynamisms, if you want to expose your queuing system outside, like we are doing, then you're better to use NAT. So.
Thank you, Omar. We have a few questions in the chat.
Yeah.
So Reda is asking if you have the same partitioning features such as Kafka.
I'm probably not the good one to respond to this question, but I guess yes. So I think it's the concept of partitioning. Maybe it has been revisited, but probably you have the same thing on Stan. Yeah. Is there any other question, guys?
Yeah, there are a few questions. Let me. Okay, so high toxicity is asking, how do you check consistency of the component? Have you set up a reconciliation process between incoming requests versus messages consumptions?
Yeah, very good question. Yeah, it's homemade. You know, when we send a request, to be sure that it has been processed, we have created a machine state, and we send the information back to the control plane. Then we know exactly if the request has been processed or not. So that's a very good question. So you have two modes. In fact, you have two modes. You know, in NAT, it's what I mentioned is that you have the fire and forget mode. So you can send a request and then you don't wait for the response, or you can request what they call a request, and then you wait directly for the response. But if you are using the request, so the synchronous one, you have to be sure that it's fast enough. But you have also a third mode, I would say, is that you are able to send like a fire and forget message, but you don't wait for the response. But the subscriber can reply to this request asynchronously. It's possible as well. It's the reply to things that they provide.
Wineb is asking about performance benchmarks. Have you some references about? I think I've seen some documentations about the NAS performances, but I don't know if you have inputs.
Yeah, they provide the tools that you need if you want to get into the performance issues. It's quite well documented. You even have like the Grafana dashboard that is ready to use to plug it to your stack, which is quite good. In our case, we are not. I think we are still. It's like sometimes we are processing like thousands of requests per second. Most of the time, it's something like that. But you know, it's a short, low number at the moment. But more we get customers, more we have users, because today we have more than 1,000 users, developers using the platform. And higher we get those numbers, then we start to benchmark the things and probably have some problems. So yeah, it's at the moment no, but probably yeah in the future.
Okay, another one from Marion. with that, you can't subscribe to multiple topics. Would be a useful feature of the any clue of how, when this would be implemented? Subscribing to multiple topics.
No, in fact, okay, I think I understand the question because you can't from one function subscribe to multiple topics. But you can, in fact, it's exactly what we did. We have multiple topics, like for infrastructure deployment or for deployment, application deployment, or even for the messages that are coming back to our control plane, and even other services like emailing and stuff like that. You can subscribe to a multiple topic, but you have to do it with a different function. So you have to call back to back those topics and subscribe to them. Yeah.
Okay. And the last one I think you already answered that question, is about the fact that Stan is more cloud native than RabbitMQ. You mentioned
Stan,
that. Yes.
Yeah.
Sorry.
Stan much more cloud native probably than Kafka, for sure. But because when you look at Kafka, for instance, you have the zookeeper things and stuff like that.
The question was about RabbitMQ. I'm mistaken. Maybe I'm mistaken when I said that.
Yeah. No. You said RabbitMQ. It's
okay.
Great, but the person talked about Stan. So you have the difference. Stan is the you can compare it as to Kafka, and NATS the reverse, the yes. Real name NATS. You can compare it to RabbitMQ. And I responded to the Stan with Kafka, and for NATS with RabbitMQ, it's also more cloud native, which means dynamic. You know, the ecosystem is dynamic. You can have multiple subscribers, producers at the same time. It can upscale and downscale. So yeah, it's very dynamic.
Okay. So that's cool. Thank you, Romaric. That was a great talk. We didn't have a talk on NAS yet, so the project is interesting and deserve to be known.
Yeah, I really think too. So yeah, if you want to start using NATS, just go on that nats.io. It's an incubated CNCF project, by the way.
Yes, High Toxicity said that yes, with StreamZ. I don't know if you know StreamZ, the operator. Romaric. StreamZ is basically a Kafka operator, so it makes installation and operation easy on Kubernetes.
Okay. Yeah, but you still have the problem of maintenance, you know, like with the zookeeper, a service that you have to maintain. You need to have that. It was part of the equation, you know, to have something that is low maintenance, because we are still a small team. We don't want to spend time on those things. We want it to get started as soon as possible. So that's why the choice was mostly that.
Cool. Thank you, Romaric. Thank you, Matt, again. So that was the first event of 2021.
Yes.
So,
and I think that we can go back to French just for the ending.
Okay.
Merci à tous d'être venus à ce premier meetup de 2021. On va relancer la machine. Comme tu disais tout à l'heure, hein, Smaïn, on est en train de migrer vers une nouvelle plateforme pour gérer les événements. Donc, plateforme commune en fait à l'ensemble des meetups de la CNCF. Donc, on va encore utiliser, je pense, Meetup quelques mois. Et puis, à un moment ou à un autre, il faudra arrêter. Donc, normalement, vous avez tous été migrés. Si vous étiez inscrit sur Meetup, vous avez été migrés vers Community. Sauf si vous êtes inscrit récemment. Donc, dans ces cas-là, il faudra probablement que vous le fassiez à la main, ou vous faites lors du prochain événement, par exemple. Voilà. Est-ce que tu veux rajouter quelque chose, Smaïn?
Non,
j'ai vu qu'il y avait Reda est notre larron. le troisième larron. Et dans le chat, est-ce que si tu veux rajouter quelque chose, Réla, tu peux toujours l'écrire. Et ben, sur ce, je pense que on va vous souhaiter à tous une bonne soirée. I would like to thank you, Matt, again, and Romaric again for coming. So see you next time. I don't know exactly when. I don't even know the program.
We have a pretty, maybe in mid-March, we have another event coming mid-March, the second part of March.
On vous enverra donc des informations un petit peu plus précises quand on aura eu confirmation de la part des speakers. On vous remercie beaucoup. On vous souhaite une bonne soirée.
Merci.
Salut à tous. Et comme ça a été enregistré, on va essayer de publier en fait une vidéo pour les gens qui n'ont pas pu venir. Merci beaucoup.
Super, merci, au revoir. Ciao.
Au revoir, bye bye.